So as I already explained how to do these connections for Wien bridge oscillator. So first of all you need to apply this plus or minus 12 volts to the op amp, plus or minus 12, and then connect this resistance R4 to the 7 and 8 here in parallel with the capacitor, and here in series with the capacitor, that is terminals are 9 and 10, connect this R8. Okay, this R4 and R8 value are internally it is 10 kilo ohms. Okay, so that is given in manual. And now you need to check the output of this Wien bridge oscillator from these two terminals. Okay, here it is given V out and it is ground. Okay, so with the help of CRO I am checking the output by adjusting this VR3 resistance. You can tune the waveform in CRO. Okay, so adjust this VR3 position until you got the pure sinusoidal waveform in the CRO. After that, note down the frequency from the CRO. Okay, now I am changing this VR3 knob and try to observe the waveform in CRO. Okay, so now I am changing the VR3 knob. Okay, now you can see the sinusoidal waveform. Actually it is getting clipped at the peak points. Okay, but you need to get the pure sinusoidal waveform. Okay, so at this position you got pure frequency, pure sinusoidal waveform, and you need to note down the frequency. Okay, so here now I selected the channel 2 in the CRO, that's why the color is somewhat changed, it is blue color. That means I'm using second channel of the CRO. Okay, so now you can see the blue color inside, it is frequency, how much? 1.506 kilohertz. Okay, so you can take this reading 1.51. I'm taking 1.51 kilohertz pulse. So here with the help of this theoretical frequency you are getting 1.59 kilohertz, and in the CRO it is around 1.51 kilohertz. Okay, and this theoretical frequency, how you got this 1.59 kilohertz? With the help of this formula, it is 1 by 2 pi square root of R1, R2, C1, C3, C4. C3 and C4 values are already fixed inside the setup. So it is 10 nanofarads. You can take it as 10 nanofarads. And what about this R78, R9, 10? Here 78 represents the resistance between 7 and 8 terminals, and the resistance between 9 and 10 terminals. Okay, so which I have connected as R4 and R8, that is 10 kilo ohms. Okay, so in this formula you need to take 10 kilo ohms for resistance, R78 10 kilo ohms, R9 10 kilo ohms. Similarly C3 and C4 as 10 nanofarads. Okay, now similarly then you will get this theoretical frequency, and you can calculate the error between theoretical and practical frequency. Okay, this practical frequency you have noted down from CRO. Okay, now we'll go for the second one, which is R5 and R9. We are going to change the resistance to the 20 kilo ohms. Okay, now I'm changing the connections in the setup. So I'm giving to the 7 and 8 terminals to the R5, and this 9-10 terminals to 23 and 24, that is R9. Okay, so now I have given the resistances R5 and R9, that is R5 and R9 is 20 kilo ohms, that is given in manual. That resistance is fixed in this setup. Okay, now once again we will adjust the frequency. So now I have connected the resistance with R5 and R9, that is 20 kilo ohms. Okay, for that, by adjusting the VR3 position you will get this sinusoidal waveform, and we are getting this practical frequency as 751 Hz. Okay, so check this frequency with theoretical frequency. Okay, so it is 751. So the practical frequency is 751 Hz, and you calculate this theoretical frequency by this formula. Here in place of R substitute 20 kilo ohms. Capacitance is already fixed, it is 10 nanofarads. Okay, and then calculate the error between theoretical and practical frequency. Now we'll go for the third one, that is R6, so it is internally 39 kilo ohms. Okay, so now I am giving the connections to R6 and here R10, R6 and R10. Okay, so now once again you need to adjust this VR3 until getting pure sinusoidal waveform in CRO. Okay, so for the third one I have selected 39 kilo ohms for R6 and R10. Now I am adjusting this VR3 knob for getting sinusoidal waveform. So now you got this sinusoidal and with the frequency it is 386 Hz. Okay, so note down this frequency. So it is 386 Hz and you calculate this theoretical frequency with the help of this formula. In place of R, substitute 39 kilo ohms. Okay, it is 39 kilo ohms. And then now we'll go for the last reading, that is R7 and R11, which is 100 kilo ohms fixed internally. Okay, so now I'm changing the connections to R7 and next here it is R11, that is 100 kilo ohms. Okay, so for this one the resistance is 100 kilo ohms. Now I'm adjusting VR3 for getting pure sinusoidal waveform. If you keep on rotating this knob, the waveform will be distorted like this. Okay, there will be some clipping effect. Okay, so we need to get pure sinusoidal waveform. Then at this position note down the frequency. How much it is? 152 Hz. Okay, you can take it as 152 Hz. Okay, so it is 152 Hz and you calculate the frequency using that formula by substituting 100 kilo ohms and calculate the error between these two. Okay, measured value, that is practical, minus true value, that is theoretical, by true value, that is error formula. Okay, that's it.